What's up everyone, it's Bucky and welcome to your third networking tutorial. Today we're going to be going over something called network topology. The first thing I want to show you guys is a term I'm going to be using, and this is called protocol. Now what protocol is how data is formatted, transmitted, and received. So just in case I use that term, it pretty much just means how you send data over the network. And before we get started, another term I wanted to go over that you guys are going to be seeing a lot is called topology. Now topology is pretty much just the design of the network, and physical and logical. The physical means what you can actually see, and the logical means how data is transmitted, so you can't usually see that. And there are four major types of topologies, or how the network is laid out, and those are called bus, ring, star, and mesh topology. The first one we're going to be going over is something called a bus topology. And what this is pretty much you have a cable right here, and on either side of the cable you have something called a terminator. Now what a terminator's job is, it absorbs electric signals, so when the data reaches the end of the network, then it doesn't mirror back and create a bunch of noise. Whenever data reaches one of these ends, it just gets destroyed. And how the computers are set up in this network is something like this. You have a computer right here, and you have a server right here, and you have a laptop right here, and they're all linked into this network kind of like a chain. And this is kind of like a bus, because if this one wants to send data to this, it has to go through all the other nodes or all the other things connected to the network before it gets to here. So say you wanted this computer right here wanted to send data to this laptop. It would have to first travel along here, stop at the server, then keep going and go to the laptop. Then once it gets to this terminator right here, it disappears, so it can't be transmitted back and you don't have a bunch of noise or anything. So that's how that works. The next layout I wanted to go over is called the ring topology. And what a ring topology is, geez, I keep messing that up, is pretty much a ring of cable, and all of your computers are connected to a point outside the ring, kind of like this. So in a ring, it's one continuous path, and there aren't really any beginning or ending paths. So whenever a computer wants to transmit data to another computer, say this computer wants to transmit data to here, you can either go this way or this way. And as you can see, there are no terminators in this. It's a lot different. That's one of the main reasons it's different than bus topology. So pretty much the nodes are attached at points around the ring, and the data goes from node to node until it reaches its destination. And there can be as many computers you want on a ring topology. So if you want to transmit data from this node right here to this one, it will first travel along the cable, stop right here, travel along, reach its destination, and that's where it ends up. And the next topology I want to go over is something called a star topology. Now what a star topology is actually one of the oldest topologies, and it's multiple nodes attached to a central device. So in the middle you have something called a switch, and you'll see what that does in a second. That's a pretty good looking switch right there. And you have a bunch of computers or servers or anything on the outside here. These are computers, if you can't tell by my awesome drawing, and they're all connected to the middle switch or bus or router or something via cables, and this is called a star topology. Again, a bunch of nodes on the outside and a central device where they all connect to. So if computer 1 wants to transmit data to computer 2, it would first send it to the switch, and then the switch would decide what computer needs it, and then it would send it out to the correct computer. And the last topology I want to go over is something called a mesh topology. Now what a mesh topology does is kind of combine the best of both worlds from all the other topologies. You have a bunch of nodes on the outside here. Let's make 5 of them. Wow, those are some nice looking computers right there. And pretty much every node is connected to every other node, like this. Wow, nice connections. There we go. I think I got everyone. Yeah, I got everyone. So every node is connected to every other node. This one's connected to this one, this connected to this one, this one, this one. And this is useful because it's kind of like if any link breaks, then communication is still possible. Since if this one wanted to transmit data to this, it might go this way. But if this computer gets shut out, then it might go this way, and you're still in business. So it's kind of like a built-in protection. So the more nodes you have in your network, the more communication paths are possible. And because there's so much cable or communications involved in this, then it's actually really expensive. So it's not used a lot on LANs. It's used more widely in MANs and WANs and stuff like that. So if you can tell through my rough drawing that this is one of the most popular with like wide area networks in like cities and stuff like that. But that pretty much concludes my third networking tutorial. I hope you guys didn't mind my awesome drawings. And again, if you have any questions at all, go to my website, thenewboston.com, and I'll answer them there. Don't send me a YouTube message because my inbox is loaded and I never check it. So sign up at The New Boston. I hope you enjoyed my tutorial, and I will see you next time.